We present a learning-based path planning method for human-like robot arm motion generation for assistive robots like wheelchair-mounted, robotic manipulators in HRI settings to complete functional tasks with safety and predictability. The drinking task is chosen due to its high priority for motion-impaired people. We use an inertial motion capture system based on data logging IMUs to collect human demonstrations of drinking motion from 5 participants. A sample reconstructed motion is animated, where each motion sample is downsampled to 150 samples or frames and structured as a fully connected spatiotemporal graph. We employ a spatiotemporal graph neural network that follows an encoder-decoder structure where the space-time separable graph convolutional network is used to embed the motion dynamics and the decoder is used to forecast and generate the following future motion. Each temporal frame of the motion graph contains 3 nodes for the shoulder, elbow, and the wrist. A 30-frame input and 30-frame output model is trained, where the first 30-frame reaching segment is used as the first input and the rest 120 frames is generated by recursively using its output as its new input 4 times. This shows a sample predicted motion trajectory given a reaching input. The generated trajectory is mapped and scaled to the UR5V's end effector concatenated with its set orientations to form the waypoints to follow by inverse kinematics. We then qualitatively compare our STS-GCN-based approach on the left to a standard inverse kinematics-based joint space trajectory on the right. Our method displays a more human-like predictable motion that first reaches in front of the face and then approaches the mouth steadily unlike the consistent curve of the standard IK-based trajectory. To quantitatively validate and test the performance and the generalizability of the model, unknown bottle positions for testing shown in red are added to the known bottle positions in black. Now, a number of sample actual robot motion for drinking is shown for the validation and test positions. Thanks for your attention.